Welcome to the Explainer. Today we're tackling a really cool question. Can the weather actually predict your sales? By the end of this, you'll know the exact playbook data scientists use to turn simple data into powerful predictive decisions using a fantastic tool called Scikit-Learn.
So this whole thing kicks off with a question that, honestly, almost every business asks itself. How can we take the data we already have and use it to make smarter guesses about what's just around the corner? Let's figure this out with a real-world example.
So meet Jeff. He's got this ice cream truck, right? And he's noticed something pretty obvious. When it gets hotter, he sells more ice cream. But just knowing he'll sell more isn't super helpful. To run his business well, he needs to know how much more based on the weather forecast. And this is where it gets fun, because Jeff's problem is the perfect way for us to dive into the world of machine learning. Our tool for the job is Scikit-Learn. It's the go-to Python library in the industry because it makes building these predictive models incredibly simple. It's the perfect place to start. So let's walk through the exact steps.
Okay, before we even think about writing a single line of code, we need a game plan. A professional workflow isn't just about getting an answer, it's about getting an answer you can actually trust your business with.
And our roadmap is a straightforward 4-step process. First up, we've got to prepare our data. Then, we use that data to train a model so it can learn the patterns. After that, we have to evaluate it, see how well it actually learned. And finally, we use our shiny new model to make predictions about the future. Let's start with what is, no joke, probably the most important step in this whole process: data prep. And the number one rule here is you can never use all your data to teach the model. I mean, think about it. If you did, you'd have no way of knowing if it actually learned the pattern or if it just memorized the answers. So here's what we do. We split Jeff's historical data. We're going to take the lion's share, say 80%, and that's our training data. This is what the model gets to study. And that other 20%, we lock it away in a vault. That's our test data, and it's basically the final exam for a model. Now, this separation is absolutely crucial. It helps us avoid a huge rookie mistake called data leakage. It's exactly what it sounds like. If the model gets even a tiny peek at the test data during training, it's like cheating on an exam. It might get a great score, but it hasn't actually learned anything, so it'll fail in the real world. All right, our data's prepped and ready to go. Now for the really cool part, training our very first model. And you're not going to believe this, but this is pretty much all the code you need in Scikit-Learn. It's wild. We just import the linear regression model, we create one, and then we call this magic little method .fit, feeding it our training temperatures and sales. So what's actually happening when we call .fit? Well, that is the training. The algorithm is literally crunching all those training data points and figuring out the one single straight line, the best fit line, that gets as close as possible to all of them. It is literally learning the relationship. Okay, so our model is trained, but here's the thing. That doesn't mean it's any good. We have to grade it. And this is the moment of truth. It's time to unlock that vault and bring out our test data. And how do we grade it? We use a standard metric called R-squared. The easiest way to think about it is like a report card score, from 0 to 1. 0 means the model is totally useless. 1 means it's a perfect psychic. We're obviously shooting for something as close to 1 as we can get. So we run the models.scoring method on our unseen test data, and boom! We get an R-squared of 0.92. I mean, that is awesome. It means our super simple line can explain 92% of the variation in Jeff's sales. That's a really, really strong start. But the real world is messy. It's not always a perfect straight line. What if Jeff realizes that when it gets crazy hot, like sweltering, people just stay home in the air conditioning? His sales actually go down. A straight line just can't handle that kind of curve. To deal with curves like that, we need to get a handle on two key ideas: parameters and hyperparameters. Think of it this way. Parameters are what the model learns on its own from the data, like the slope of that line. But hyperparameters, those are the settings we control. They're the knobs and dials we get to tune before we even start the training. And turning those knobs brings us to this classic balancing act in machine learning, the bias-variance tradeoff. If your model is too simple, it has high bias, and it's going to underfit and just completely misses the real pattern. But if you make it too complex, it has high variance, and it's going to overfit. It basically memorizes every little random blip in your training data and then totally falls apart when it sees new stuff. The name of the game is finding that sweet spot right in the middle. So here's the really crucial part. We didn't just build some math equation. We built a tool for the business.
Now let's see how we can turn what this model learned into actual, actionable advice for Jeff.
One of the great things about a simple model like linear regression is that it's transparent. We can literally pop the hood and see what it learned. We can grab the two key parameters, the coefficient underscore, which is just the slope of our line, and the intercept underscore, which is where that line starts.
And these numbers aren't just for a spreadsheet. We can translate them directly into plain English. Now, if Jeff sees the weather forecast is going to be 3 degrees hotter tomorrow, he knows that means he should plan for about 76 more in sales. That is a data-driven decision. So, let's wrap this up with a little checklist for you. When you're ready to start your first Scikit-Learn project, this is your roadmap. Always split your data, no exceptions. Watch out for data leakage, start simple before you get fancy, grade your model. Understand that bias-variance balancing act, and maybe the most important thing of all, turn your model's math into something a human can actually use. You know, we built a really solid model using just one piece of information, the temperature, but that's just scratching the surface. So I'll leave you with this to think about. What else matters? Is it a weekend, a public holiday, the time of day? Every one of those new pieces of data is another chance to build an even better, even more powerful model.
Like and subscribe for Simplify Tech, explaining one concept at a time, simplifying the technology and AI.